binary search algorithm. Shall we start, guys? Is anyone having any doubt in the last session? अगर कुछ डाउट होगा तो पूछो जल्दी से क्विकली, otherwise we can start with binary search. Okay, so shall we continue, guys? Shall we start? Okay, very good. How many students joined yet? Let me check. 56 students, right? So what kind of in exam, programs or theory? No, आपको programs नहीं पूछेंगे तेजस्विनी, programs नहीं पूछेंगे. And don't worry, today I'm going to share questions with you, MCQs, so that you will get an idea that which kind of questions may get asked into the CCAT, right? But believe me, अगर आप देखोगे मैंने कल yesterday only I told you, yes, mostly all the questions are concept or pseudocode oriented. आपको programming का एक भी question नहीं आएगा. No one will want to ask you to write program or to find the output, right? Okay, so shall we start? Because it's 12:02, right? So I think we should start, or should we wait for some time? Wait kare 1-2 minutes. Rahul sir, what is expected count? I guess 100, na?
116, but 100 is expected.
Okay, I think 60 students joined so far. I can see over here. So should we wait for some time? Okay, by the time अगर कुछ डाउट हुआ किसी को और तो पूछो, so that within next 1 or 2 minutes others also will join and we can start with the today's contents. Okay, I think we should start because it's already 12 o'clock, 12:03, right? Because again we are having every day only 2 hours, right? So we should start. So in binary search, very first you must remember 2 points. Point number 1, that this algorithm follows divide and conquer approach. So what exactly divide and conquer approach is, don't worry, we're going to see with the help of example ki exactly kya hota hai, right? So but that binary search algorithm follows which approach? Divide and conquer approach. Sir ये क्या होता है, ये हम लोग पढ़ने वाले हैं. Then second point, need to remember you guys, that is if you want to apply binary search on an array, prerequisite is that array elements must be in a sorted manner. क्या होने चाहिए? array elements must be sorted manner होने चाहिए, right? Sir, is this condition is this a prerequisite for a linear search? Linear search के लिए ऐसा कुछ condition है क्या? No, for linear search ऐसा कुछ condition नहीं है. So for binary search, prerequisite is that yes, array elements must be present in a sorted manner. ये उसका prerequisite है, right? Now we discuss about its logic. What exactly happens in this, right? Or actually, what is the logic in this algorithm? In first iteration, by means of calculating big size array gets divided into 2 sub arrays, right? So ये जो division हो रहा है, ये logical division होता है. So logically, big size array gets divided into 2 sub arrays, left sub array and right sub array, right? And key element gets compared with element which is at mid position. So if key is found at mid position in first iteration in only one number of comparison, then it is considered as best case. उसे कौन सा case consider किया जाएगा? Best case. And in this case, an algorithm takes order of 1 time. Why order of 1? Because number of comparisons are only 1 in best case. So this is the best case for binary search, right? Then if key is not found in the first iteration, then either key will get searched into the left sub array or it will get searched into the right sub array by applying same logic repeatedly till either key is not found or maximum size of sub array is valid. That is, size of sub array is greater than or equal to 1. Okay, we'll try to understand this logic with the help of example, right? So guys, are you with me? उसके पहले यहाँ पे linear search का लिखे time of it is best case. Yes, can you recall guys what we learned yesterday? Big omega of Hello friends, big omega of 1. Very good. Worst case is big OH of n. And what about average case? Big theta of n only. Is that fine? Big theta of n. Can you recall this? ये टेबल बहुत इंपॉर्टेंट है आपके लिए और इसीलिए मैंने यहाँ पे एक्सेल शीट लिखा, राइट? सो दिस टेबल इज वेरी इंपॉर्टेंट फॉर यू, राइट? तो आपको एग्जाम में ये इंपॉर्टेंट है. This is very very important for you people, right? Okay, now we are going ahead with the binary search, right? In binary search algorithm, can you please tell me guys what is size of an array quickly? Please reply me, what is size of an array? Yes, very good. Now on array elements must present in a sorted manner. So are these array elements are sorted? Yes, sorted hai, right? In an ascending order, right? Sorted hai, right? Now what this algorithm logic says, in first iteration we need to calculate mid position. Sir, but how we can calculate mid position? So to calculate mid position, can we say 0 is the leftmost position? Can we say 0 is the leftmost position? And yes, 9 is the rightmost position. Hello friends, do you agree with this? So 0 is leftmost position, 9 is rightmost position. It is size minus 1, right? Now how we can calculate mid? We can calculate mid by saying left plus right divided by 2. That will be equal to 0 plus 9 divided by 2. Now we know that division of two integers is what? Integer only, right? And we are interested to calculate position. So all these positions are of type integer, and hence we'll get answer as 4 in first iteration. In first iteration, we'll get the value of mid as 4. Are you with me, friends? Have you understood this? So by means of calculating mid position, this big size array has been divided into two sub arrays. Left sub array and right sub array. Do you agree? Friends, can you see? So ये जो array है having size 10 has been divided logically into two sub arrays, left sub array and right sub array. So we're going to refer it as left sub array, and we'll refer it as right sub array, right? और इसी को बोलते हैं divide and conquer approach. It means we are dividing problem into two sub problems. हम लोग अभी यहाँ पे क्या कर रहे हैं? We are dividing problem into two sub problems, right? Now let's say for example, assume कर रहे हैं, let's say value of key is equal to 50. क्या है key का value, friends? Value of key is 50, right? Now for value of key is 50, in first iteration what we need to do? In first iteration, by means of calculating mid position, we divide a big size array into two sub arrays, left sub array and right sub array, and then we need to compare value of key with element which is at mid position. What is the value of mid, guys? Reply me. अरे हमने ये assume किया है. How value of key is 50? We are assuming this is the one of the possible case. This is what one of the possible case. हो सकता है क्या key का value 50? Yes, value of key may be anything. Hello friends, are you getting what I'm saying? तो हम अभी assume कर रहे हैं. Let us assume for the value of key as 50. So if the value of key is 50, then don't you think after calculating mid position, we're going to compare value of key with element which is at mid position. So value of key gets compared with element at mid position, that is 50. So is this 50 or is a key is equal to error of mid? Yes, and the best case. This is the best case. So if key is found, in very first iteration, in only one comparison, can we say it is the best case? Hello friends, can we say it is the best case? Right? So this is the best case, right? And in best case, Can you please tell me how many number of comparisons are there total? Number of comparisons are only one, right? And hence, can we say running time is order of 1? Can we say running time is order of 1? Hello friends, are you with me? Are you with me? So this is the best case. ये कौन सा केस है? ये बेस्ट केस है, right? Now pay attention. So what if value of key is, let's say, is equal to 90? सर अगर की का वैल्यू, अरे हमने पहले केस कौन सा कंसीडर किया? ये बेस्ट केस कंसीडर किया. So we consider best case, right? Now we consider for another value of key, right? Now if the value of key is 90, pay attention. If the value of key is 90, again in first iteration we calculate mid position. In first iteration we'll calculate mid position, right? So in first iteration what will be the value of mid? In first iteration value of mid is 4. Agree with this? Value of mid पूछ रहा हूं मैं. Value of mid is 4 and value at mid position is 50. Please listen carefully what I'm saying. Value of mid is 4 and value at mid position is 50, right? So in first iteration we are calculating mid position as 4, right? Mid is index, very good. And hence after calculating mid position, or by means of calculating mid position, this big size array has been divided into two sub arrays, left sub array and right sub array. Then we'll compare value of key with element which is at mid position. So value of key now in this case, in second case, we have assumed value of key as 90. So this 90 gets compared with 50. Yes, is value of key is equal to error of mid? No. So this is not the best case. This is not the best case. So we have to go for next iteration. We have to go for next iteration, right? Now, so do we need to search in both the sub arrays? हमें दोनों सब array में search करने की जरूरत है क्या? No. And hence that's why it is what called as binary search, or we can say divide and conquer approach. It means we are dividing problem into sub problem, right? It means we'll want to check if value of key is not mid position element, then we'll check is it less than mid position element? Is 90 or is the value of 50? No. So if it is not less than 50, then don't you think we'll want to skip one left sub array? We'll want to skip one left sub array. No need to check or no need to search key 90 into the left sub array, because it is not possible. अगर की का वैल्यू मिड पोजीशन एलिमेंट से अगर ग्रेटर है, सो लेफ्ट सब एरे में होना वो पॉसिबल नहीं है. डू यू एग्री विद दिस? एंड हेंस by skipping one left sub array, we'll want to search key only into the right sub array. We'll want to search key only into the right sub array. Don't worry, ये repeat होगा, right? So let's say in first iteration, pay attention. In first iteration, what we are doing? We are comparing value of key with mid position element. Can you please tell me what is the value of mid position element? 50. So is 90 is equal to 50? No. It means, is this the best case? Atharva, is this the best case? It is not the best case, right? Now, if key is not found at in first iteration, then either key may exist into the left sub array or key may exist into the right sub array. तो हमें करना है और right sub array में search करना है. Do we need to search in both sub arrays? No, because अगर key का value mid position element से अगर equal नहीं है, if the value of key is not equal to mid position element, then either it is less or greater. Now, if it is less, if the value of key is less than mid position element, then it may exist or it may present into the left sub array. Definitely, it will not there into right sub array. And if it is greater than mid position element, then definitely it will not be there into the left sub array. It may exist into the right sub array. Hello friends, are you getting what I'm saying? So after every iteration, either we'll want to, if we do not found key at mid position, then either we'll want to search key into the left sub array or into the right sub array. इसका मतलब सर half of task is getting skipped और half of elements are getting skipped after every iteration. तो यहाँ पे क्या हो रहा है? Divide हो रहा है ना? अरे क्या हो रहा है यहाँ पे? Divide and conquer. It means this kind of problem solving technique is called as divide and conquer strategy. Are you getting what I'm saying? Okay, Devidas saying, but sir, if the keys are not in series, then how we can decide? अरे इसीलिए Devidas prerequisite is that, what is prerequisite? To apply binary search on an array, prerequisite is that array elements must be present in a sorted manner. Devidas, is this clear to all of you? अगर array sorted नहीं है तो we cannot apply binary search. It is a prerequisite. Now what do you mean by prerequisite? मतलब वो कंपलसरी होना ही चाहिए. क्या स्टूडेंट सीडैक कोर्स कर सकता है क्या? अगर किसी ने बीकॉम अगर बीए किया है तो वो कर सकता है क्या सीडैक कोर्स? नो. सो सीडैक कोर्स करने के लिए prerequisite is that yes, you must have completed either BE or MSc or MCA. अगर तीनों छोड़ के अगर किसी ने कोई दूसरा डिग्री किया है और एमटेक, राइट, मतलब ये प्रीरिक्विजिट है, कंपलसरी. इफ यू वांट टू अप्लाई बाइनरी सर्च, prerequisite compulsory is that array elements must present in a sorted manner. I hope it is clear now, right? Okay, now what is the value of key? Value of key is 90. So is 90 is less than 50? No sir. अगर equal नहीं है, less भी नहीं है, so it may present into the right sub array. It may present into the right sub array, and hence by skipping वो left sub array, we'll want to search key into the right. Now for right sub array, can you please tell me guys, pay attention. For right sub array, value of right remains as it is. Right का value as it is रह रहा है, right? So what will be value of left? It means देखो हम लोग यहाँ पे क्या कर रहे हैं? Yes, we are dividing array into two sub arrays. So mid plus one, mid नहीं, mid plus one. हेलो फ्रेंड्स, राइट सब एरे का जो लेफ्ट है वो कहां से स्टार्ट होगा? मिड प्लस वन से स्टार्ट होगा. आर यू विथ मी गाइस? वो कहां से स्टार्ट होगा? मिड प्लस वन से स्टार्ट होगा, राइट? इट मींस फॉर राइट सब एरे वैल्यू ऑफ लेफ्ट विल बी मिड प्लस वन, राइट? सर अगर हम लेफ्ट सब एरे में आते तो if you talk about a left sub array, so for left sub array, can you see guys, value of left remains as it is and value of right will be mid minus one, mid 4 minus 1, right? तो ये होगा right उसका. Do you agree with this? Right? So let me write it over here. मैं यहाँ पे लिख के रखता हूँ, right? If value of key or for left sub array after division or after iteration or after finding or after dividing array into two sub arrays, yes, for left sub array value of left remains as it is, right? And value of right will be equal to what? Mid minus one. Do you agree with this? Right? And for right sub array, for just a minute, ये क्या हो रहा है? Okay, for right sub array क्या होगा ये? Yes, for right sub array value of right remains as it is and value of left will be what? और लेफ्ट का वैल्यू क्या होगा? मिड प्लस वन. हेलो फ्रेंड्स, हैव यू अंडरस्टूड दिस? आपको ये समझ में आया क्या? हैव यू अंडरस्टूड दिस? राइट? ओके, तब तक आप एक काम करते हैं, एक 2 मिनट के लिए सिर्फ आप ये चेक करो, राइट? जस्ट 2 minutes, you can check this diagram. Okay, I'm sorry, I want to share the screen with you. एक मिनट, डोंट वरी, रिपीट होगा कल्पेश, डोंट. तब तक आप लोग ये जरा एक बार देख लो यहाँ पे, राइट? जस्ट अ मिनट. Okay, all of you, are you there? Hello friends, are you there? Okay, pay attention, pay attention, let me repeat. अरे ये की हम लोग एज्यूम कर रहे हैं, एज्यूम, ये की फाइंड नहीं कर रहे हम लोग। अगर की का वैल्यू 50 होगा तो क्या होगा, अगर की का वैल्यू 90 होगा तो क्या होगा, हम लोग एज्यूम कर रहे हैं एंड वी आर हैंडलिंग डिफरेंट डिफरेंट केसेस। तो ये प्लीज, हमने जैसे लीनियर सर्च के लिए, अरे व्हाट डू मीन बाय सर्चिंग, प्लीज अप्लाई योर कॉमन सेंस। if we are having if we apply linear search, right, what do you mean by searching? To searching means to search a key in a given array or given collection or list of elements. अब ये की का वैल्यू क्या हो सकता है, बताओ मुझे कोई। की का वैल्यू कुछ भी हो सकता है ना, present into the given array or key may not be present into given array। अरे की हो भी सकता है इसमें, की नहीं भी हो सकता है, इसलिए हम लोग सर्च करें ना कि whether it is found or not। So value of key may be anything, value of key may be anything। हाँ, लेकिन obviously it must be of type integer, it may be -5, it may be 100, it may be 25, it may be any value। Hello friends, have you understood this? आपको एक की का समझ में आया क्या? So please, ये की का वैल्यू कैसे फाइंड किया, ये मुझे क्वेश्चन मत पूछो, ये बहुत ही सिंपल है, हम लोग ये एज्यूम कर रहे हैं। वी आर एज्यूमिंग वैल्यू ऑफ की इज 50। अगर की का वैल्यू 50 है तो फिर कौन सा केस है? If value of key is 90, then what is the case? If value of key is anything else, then what will be the case? हम लोग को डिस्कस करने वाले हैं। तो की का वैल्यू फाइंड नहीं करते हैं। आर यू गेटिंग व्हाट आई एम सेइंग गाइस? की का वैल्यू फाइंड नहीं करते, राइट? की का वैल्यू हम लोग क्या कर रहे हैं, यहाँ पे एज्यूम कर रहे हैं। वी आर एज्यूमिंग। इज दैट फाइन? सो अगर हमारे पास इंटीजर टाइप का एरे है, इंटीजर टाइप के एलिमेंट्स का एरे है, राइट, और अगर उस एरे में अगर 100 एलिमेंट्स है, और अगर आप बोलोगे मुझे कि सर मुझे ये एलिमेंट सर्च करना है, राइट, लेट्स से दिस एलिमेंट सर्च करना है, तो एलिमेंट कौन सा टाइप का होना चाहिए? इफ यू वांट टू सर्च की इनटू इंटीजर टाइप ऑफ एलिमेंट्स, एरे ऑफ इंटीजर्स, सो ऑब्वियसली की मस्ट बी ऑफ विच टाइप? इंटीजर। सर की का वैल्यू क्या होना चाहिए? वैल्यू ऑफ की में भी एनीथिंग ना। अरे की का वैल्यू कुछ भी हो सकता है, की का वैल्यू कुछ भी हो सकता है ऑफ टाइप इंटीजर। वो एरे में हो भी सकता है, नहीं भी हो सकता है, यही तो हमें फाइंड करना है, वेदर इट इज फाउंड, वेदर इट इज प्रेजेंट और नॉट। अरे इसी को सर्चिंग बोलते हैं ना। हेलो फ्रेंड्स, आर यू गेटिंग व्हाट आई एम सेइंग? नाउ व्हाई फोर्थ, व्हाई नॉट फिफ्थ? बिकॉज हम लोग यहाँ पे मिड पोजीशन कैलकुलेट कर रहे हैं। इट्स अ डिवाइड एंड कॉन्कर अप्रोच, इट्स एन एल्गोरिथम, राइट? व्हाट इज डिवीजन ऑफ टू इंटीजर्स? अरे आपको डिवीजन ऑफ टू इंटीजर क्या आता है, ये मुझे बताओ। 9 डिवाइड बाय 2। डिवीजन ऑफ टू इंटीजर्स इज व्हाट? अरे डिवीजन ऑफ टू इंटीजर्स इज व्हाट? मैं इंटीजर का डिवीजन पूछ रहा हूं। आप लोगों ने सी प्रोग्रामिंग लैंग्वेज में डिवीजन ऑफ टू इंटीजर किया है, राइट? तो 4.5 आंसर हो सकता है क्या? अगर आप लोगों ने सी प्रोग्रामिंग लैंग्वेज में डिवीजन, इन सी प्रोग्रामिंग लैंग्वेज, व्हाट इज द आंसर ऑफ 9 by 2? 4 और 5? 4 ना, राइट? तो इसीलिए मिड का वैल्यू क्या मिला, यहाँ पे 4 मिला। इज दैट फाइन? नहीं, 5 क्यों लेंगे ऋषि लगड़? व्हाई 5? बिकॉज इंटीजर, डिवीजन ऑफ टू इंटीजर इज व्हाट? 9 by 2 का आंसर क्या मिलेगा आपको प्रोग्रामिंग में? ऋषिकेश, आर यू देयर? बताओ 9 by 2 का आंसर क्या मिलेगा आपको? 4 मिलेगा या 5 मिलेगा? अरे प्लीज म्यूट योरसेल्फ। Rushi, please reply me. In C programming language, 9 by 2, what answer you will get? अरे एरर नहीं देगा, आपको डिवीजन मिलेगा ना। आपका सी प्रोग्रामिंग लैंग्वेज वीक है, इसका मतलब, राइट? इन सी प्रोग्रामिंग लैंग्वेज इफ यू डू डिवीजन, अगर आप डिवीजन करोगे, राइट, डिवीजन करोगे तो आपको आंसर मिलेगा 4, राइट? एंड इफ यू डू मॉड्यूलर डिवीजन, अगर आप ये, तो आपको रिमाइंडर मिलता है इसमें। ये आपने किया है क्या ऑपरेशन सी प्रोग्रामिंग लैंग्वेज में? ऋषि, हैव यू डिड दिस ऑपरेशन, राइट? तो हाउ आप 5 कैसे ले सकते हो? नो, वी कैन नॉट टेक 5, वी हैव टू टेक 4 ओनली। इज दैट फाइन? ओके, नाउ पे अटेंशन। अभी ये जो लॉजिक है, डोंट वरी, ये लॉजिक रिपीट होगा, राइट? हम लोग अभी की का वैल्यू क्या एज्यूम कर रहे हैं? अरे इन फर्स्ट केस व्हाट वी एज्यूम? इन फर्स्ट केस वी हैव एज्यूम वैल्यू ऑफ की एज 50, right? Now, if value of key is 50, for value of key is 50, if it is found at very first iteration in at mid position, तो वो कौन सा केस है? Hello friends, it is which case? It is a best case. When best case occurs if key is found in very first iteration in only how many number of comparisons? In only one number of comparisons. तो आपको इस की, अगर की का वैल्यू 50 होगा, अगर की का वैल्यू 50 होगा तो कौन सा केस होगा, ये समझ में आया आपको? राइट, ओके, नाउ वी आर कंसिडरिंग अनदर केस. हम लोग अभी अनदर केस एज्यूम कर रहे हैं. इफ वैल्यू ऑफ की इज इक्वल टू 90, सर अगर की का वैल्यू 90 है तो फिर क्या होगा? नाउ वी आर थिंकिंग अबाउट सेकंड केस, राइट? ओके, सो इफ 90, और अगर आपको बोला कि 90 को सर्च करो इस एरे में, तो व्हाट इज द फर्स्ट स्टेप? In first iteration, what we have to do? In first iteration, we have to find the mid position. So in first iteration, what will be the value of mid? First iteration में mid का value क्या आएगा? रिप्लाई दो, 4 आएगा, right? Are you with me? ये रिपीट हो रहा है. Value of mid will be 4. Value of mid will be 4. 50 value mid position का एलिमेंट है, right? Okay, so value of mid will be 4 and value at mid is 4. Now after or by means of calculating mid position, सर ये mid position कैलकुलेट करने से क्या हुआ है? By means of calculating mid position, big size array has been divided into 2 sub arrays. तो सर mid के पहले left till mid minus 1, whatever is there will be referred as left sub array. So left till mid minus 1, ये क्या है? left sub array है. And from mid plus 1, the right sub array. Hello friends, have you understood this? So by means of calculating mid position, big size array has been divided into 2 sub arrays, left sub array and right sub array, right? Then what we need to do after calculating mid position, we need to compare value of key with element at mid position. So can you please tell me what is the value of an element which is at mid position? 50. So 50 gets compared with 90. So is 90 is equal to 50? No, it means key is not found at in first iteration. So is this the best case? No, this is not the best case. So either key will get searched into the left sub array or it will get searched into the right sub array. So why this is so? Because pay attention, as all array elements are already sorted, right? So if key is less than mid position element, so it may exist into the left sub array and it is definitely not present in the right sub array. But if it is greater than mid position element, तो वो सर लेफ्ट सब एरे में नहीं होगा, it may exist into the right sub array. Have you understood this? अरे आपको ये समझ में आया क्या? Right? Okay. Then we'll check is 90 is value of key is less than 50. अगर वो इक्वल नहीं है तो either वो लेस होगा या तो क्या होगा? ग्रेटर होगा. So is it less than 50? No, it is not less than 50. It means definitely it is not there into the left sub array. बिकॉज लेफ्ट साइड एरे में सारे एलिमेंट ऐसे ही है जो मिड पोजीशन एलिमेंट से क्या है? स्मॉलर है. सर अगर की का वैल्यू इससे स्मॉलर नहीं है, सो डेफिनेटली की विल नॉट देयर इनटू द लेफ्ट सब एरे एंड लेफ्ट सब एरे विल गेट स्किप्ड. इट मींस की मे एग्जिस्ट इनटू द राइट सब एरे. और हम चेक कहां पे करेंगे? विल वांट टू चेक ओनली इनटू द राइट सब एरे इन नेक्स्ट इटरेशन. हेलो फ्रेंड्स, हैव यू अंडरस्टूड दिस? सो इन नेक्स्ट इटरेशन विल गो इनटू ओनली राइट सब एरे, विल गो key in only into the right sub array, right? Now in right sub array, value of left is 5, value of right is 9. Again, can we apply same logic? Again, we can calculate mid position. Mid is equal to left plus right divided by 2. That will be equal to 14 divided by 2. अभी मुझे आंसर बताओ, इसका डिवीजन क्या आएगा? 7 आएगा, right? So division is 7 and hence in this iteration value of mid will get as 7. 7 मिला क्या वैल्यू मिड का? राइट. इट मींस सर हमने फिर से क्या किया यहाँ पे? वी हैव कैलकुलेटेड मिड पोजीशन एंड वैल्यू ऑफ मिड पोजीशन इज वैल्यू एट मिड पोजीशन इज 80. सो बाय मींस ऑफ कैलकुलेटिंग मिड पोजीशन अगेन वी हैव डिवाइडेड एरे इनटू, अरे क्या हुआ यहाँ पे? एरे हैज बीन डिवाइडेड इनटू हाउ मेनी सब एरेज? 2 सब एरेज. सो फ्रॉम लेफ्ट till mid minus 1 will be the left sub array and from mid plus 1 till right will be the right sub array. Have you understood this? मैं जो कुछ बोल रहा हूँ आपको समझ में आ रहा है क्या? Right? And hence what we are doing, yes, or what we'll do, it means मैं यहाँ पे ड्रॉ कर रहा हूँ आपको समझने के लिए, right? So this will be referred as, इसे क्या रेफर किया जाएगा? It will be referred as left sub array, right? And it will be referred as right sub array. It will be referred as left sub array. It will be referred as right sub array. Right? Now for left sub array, value of left remains as it is. सर लेकिन ये स्टार्ट कहां से हो रहा है? लेफ्ट टिल मिड -1. तो सर राइट का वैल्यू क्या होगा? मिड -1. डू यू अंडरस्टैंड दिस? अरे ये समझ में आया क्या आपको? राइट? ओके. नाउ वी सर्च एट लेफ्ट साइड एंड राइट साइड, आइदर लेफ्ट और राइट. आइदर विल सर्च इनटू लेफ्ट सब एरे. साइड यूज मत करो, डोंट यूज साइड वर्ड. यहाँ पे मैंने वर्ड यूज क्या किया? लेफ्ट सब एरे और राइट सब एरे. प्लीज यूज प्रॉपर वर्ड्स, technical words, right? Left sub array or right sub array. So either we'll want to search into left sub array or we'll want to search into right sub array. So for left sub array, value of left remains as it is after division. Value of right will be mid -1, and for right sub array, value of right remains as it is. Value of left will be mid +1. Hello friends, ये समझ में आएगा सबको? Right? Okay, it means by means of calculating mid position, array has been divided into two sub arrays further. Now we'll compare value of key 90 with this mid position element. So what is the value of mid position element? 80. Is 80 is equal to 90? Value of key is equal to the error of mid? No. If it is not equal, then either key present into the left sub array or into the right sub array. If it is less than mid position element, then it may exist into the left sub array. Otherwise, it may exist in the right sub array. तो हम यहाँ पे कंपेयर करेंगे. Is a key is less than 80? No, and hence yes, left sub array will get skipped, and we'll search only into the right sub array. We'll go to search key only into the right sub array. Hello friends, and hence we have to go for third iteration. We have to go for iteration number 3, right? Now it means we'll want to consider only, or we'll want to search only key into the right sub array, right? Again, what we can do, we can calculate mid position over here. Yes, mid is equal to अरे लॉजिक सेम रिपीट करना है ना हमें. 8 + 9 divided by 2, that is equal to 17 divided by 2, that is equal to, बोलो आंसर क्या आएगा? 8 आएगा. Hello friends, are you with me? So division will be how much? 8. तो आंसर यहाँ पे आएगा 8 आएगा, and hence value of mid is 8. मिड का वैल्यू क्या मिला हमें? यहाँ पे 8 मिला. Understood this, right? It means what is the value at mid position? 90. It means sir यहाँ पे क्या हुआ है? देखो again, by means of calculating mid position, again we are dividing array into two sub arrays, left sub array and right sub array, right? Sir यहाँ पे left sub array valid है क्या? Is there left sub array valid over here? No, and hence here we can say left sub array is invalid. Left sub array is invalid. Whereas, so what about right sub array? Right sub array ये देखो हमारा. Sir, is this right sub array is valid? Yes, right sub array is valid because array में एक एलिमेंट हो सकता है क्या? Yes, right? Array में एक एलिमेंट हो सकता है क्या? Yes, हो सकता है, right? And hence for right sub array, value of right remains as it is. Value of left will be mid +1. तो सर लेफ्ट का और राइट का दोनों का वैल्यू क्या होगा? सेम होगा. हेलो फ्रेंड्स, आर यू विथ मी? राइट? सो लेफ्ट सब एरे एंड राइट सब एरे. हाँ, लेकिन हमें क्या करना है अभी? आफ्टर कैलकुलेटिंग मिड पोजीशन, वी नीड टू कंपेयर वैल्यू ऑफ की. We need to compare value of key with element at mid position. So value of key is what? 90. Is a 90 or is a key is equal to error of mid? Yes, and we can say key is found. In this case, what we can say? In this case, we can say key is found, right? It means in how many number of comparisons we found a key? 1. Please check. 1, 2, 1, 2 and 3. In 3 number of comparisons we found the key. Hello friends, have you understood this? आपको ये समझ में आया क्या कि 90 अगर होगा तो क्या होगा, राइट? और ये कौन सा केस है? दिस केस इज व्हाट रेफर्ड एज एन एवरेज केस. दिस केस इन एवरेज केस, राइट? नाउ इफ वैल्यू ऑफ की इज इक्वल टू 100, अरे आपको ये एवरेज केस समझ में आया क्या? ओके, नाउ वैल्यू ऑफ की इज इक्वल टू 100. सो अगर की का वैल्यू 100 है, so don't you think in first iteration, pay attention, in first iteration we found mid position, we calculate mid position. तो 100 को कंपेयर करेंगे 50 से. is 100 is equal to 50? No. Then is 100 is less than 50? No. It means we're going to search key into left sub array or right sub array. Yes, we'll want to search key into the right sub array. So we go for second iteration. Again in second iteration position, first we calculate mid position at 7. Then by means of calculating mid position, array has been divided into two sub arrays. Then we compare value of key 100. We compare value of key 100 with, yes, mid position element. Is 100 is equal to 80? No. It means again key is not found in second iteration as well, and hence we have to go for third iteration, right? So either we'll go into search key into left sub array or into the right sub array. तो हाँ, वो चेक करने के लिए हम चेक करेंगे इज वैल्यू ऑफ की इज लेस देन 80? नो. एंड हेंस definitely key will not there into the left sub array. It may exist into the right sub array, and hence we'll go into search key into the right sub array. Again in right sub array 8 and 9, again we calculate mid position. So value of mid will get as what? 8. Value of mid is what? 8, right? Then by means of calculating mid position, yes, array has been divided into two sub arrays, whereas left sub array is invalid and right sub array contains only one element. So we compare 100 with 90. Is 100 is equal to 90? No, right? Is 100 is less than 90? No. And hence we'll want to search key into the right sub array. हम लोग कहां पे जाएंगे? right sub array में जाएंगे. Now in right sub array, pay attention guys, in right sub array again value of mid will be what? Left plus right, na? That is 9 plus 9. 9 plus 9 divided by 2, that will be equal to again 9. So हमें आंसर क्या मिलेगा मिड का? We'll get mid as 9. हमें मिड का वैल्यू 9 मिलेगा, right? It means this is the mid position. It means again by means of calculating mid position, array has been divided into two sub arrays. Left sub array, right sub array, both are what? Hello friends, both are invalid ना? Both are invalid. सर इसका मतलब यहाँ पे array होगा क्या? नहीं होगा, right? Then we compare value of key with element at mid position. Sir, is value of key 100? Is it equal to 100? Yes. And hence here we can say key is found. Here we can say key is found, right? In how many number of comparisons? In 1, 2, 3, 4 number of comparisons. Are you getting what I'm saying, guys? Have you understood this possibility? Right? Now we'll check. So what if value of key is equal to, let's say, pay attention, value of key is let's say equal to 85. अरे हम लोग ये कुछ भी assume कर रहे हैं, ये कुछ भी हो सकता है, right? Let's say value of key is equal to 85, or let's say value of key is equal to, let's say 35. क्या value key का? 35, right? Okay, now pay attention. First iteration, pay attention. In first iteration we calculate mid position. So we'll compare value of, by means of calculating mid position, array has been divided into two sub arrays, left sub array and right sub array. So we'll check 35. Is 35 is equal to 50? No, right? Then we compare, is 35 is less than 50? Yes. And hence we'll go into search key into the left sub array, right? Then again in left sub array we calculate mid position. We go to second iteration. So 0 plus 3 divided by 2. बोलो क्या आएगा आंसर? 0 plus 3 divided by 2. 3 by 2, आंसर will be 1. तो mid आएगा, mid का आंसर आएगा 1, right? Value of mid will be equal to what? 1. Are you with me, friends? Right? Now in this case 35, it means again array has been divided into how many sub arrays? Into two sub arrays. Array has been divided into two sub arrays, राइट। तो इसके बाद क्या होगा, विल कंपेयर is 35 is equal to 20, is 35 is equal to 20, no, is it less than 20, no, at it means we're going to skip both left sub array, यहाँ पे लेफ्ट सब array क्या होगा, skip होगा। Hello friends, are you with me? And we're going to search key into only right sub array. Now for right sub array, value of left will be what, mid plus 1, तो ये होगा लेफ्ट का वैल्यू और ये होगा राइट का वैल्यू, राइट। सो अगेन वी कैलकुलेट मिड पोजीशन, मिड इज इक्वल टू 2 plus 3 डिवाइड बाय 2 दैट इज इक्वल टू 5 by 2। अब बोलो क्या आएगा आंसर, 2 आएगा। सो वैल्यू ऑफ मिड विल बी इक्वल टू व्हाट, 2। वैल्यू ऑफ मिड इज व्हाट, 2, राइट। इट मींस अगेन by means of calculating mid position array into two sub arrays, जिसमें लेफ्ट सब array क्या है, लेफ्ट सब array is invalid, very good। and what about right sub array, right sub array, is it valid? Yes, it is valid, it is valid, right। and then we compare value of 35 key with 30, is 35 is equal to 30, no, then is it less than 30, is it less than mid position element, no, it means we'll going to search key into the, we'll going to search key into the right sub array, हम कहां पे जाएंगे, right sub array में जाएंगे। Are you with me guys, right? and hence we go to into right sub array। sir for right sub array value का, value of left and right are same, दोनों का वैल्यू क्या रहेगा, सेम रहेगा, मतलब left and right are 3। so again we calculate mid position is equal to 3 plus 3 divided by 2 that is equal to 6 divided by 2 again 3। so mid का वैल्यू क्या आएगा, will be 3 again, right। it means we calculate mid position, right। now by means of calculating mid position we are dividing array into two sub arrays, but don't you think sir यहाँ पे left sub array भी क्या है, left sub array is invalid, right sub array is invalid, and hence yes we'll want to compare finally 35 with 40, are they equal, are they equal, no, and hence sir अगर ये left sub array ही invalid है, it means key is not found, key is not found in how many number of comparisons, 1 2 3 4। so don't you think it is also a worst case, it is also a worst case, ये भी कौन सा केस है, ये भी worst case है, this is also worst case, this is also worst case। hello friends, so हमने अलग अलग केसेस के लिए यहाँ पे कंसिडर किया है, we checked for different cases, right। okay now let me try to tell you with the help of, pay attention sir, in third iteration अगर key is equal to 90 is 8th position, then why we move ahead again, कहाँ पे की का वैल्यू क्या है बताओ मुझे पवन, इन थर्ड इटरेशन अगर की का वैल्यू 90, हाँ अगर की का वैल्यू 90 है, अरे फॉर वैल्यू ऑफ की इज 90 तो हम आगे नहीं जा रहे पवन, हम लोग आगे क्यों जा रहे हैं, हम लोग वैल्यू ऑफ की इज इक्वल टू 100 के लिए आगे जा रहे हैं। आर यू गेटिंग पवन व्हाट आई एम सेइंग, हम लोग 90 के राइट सब एरे में अगर की का वैल्यू 100 होगा तभी जा रहे हैं आगे। इफ वैल्यू ऑफ की इज 90 देन वी आर नॉट गोइंग अहेड। तो यहाँ पे इन 3 नंबर ऑफ इटरेशंस और इन 3 नंबर ऑफ कंपैरिजंस, अरे इसलिए मैंने इसको एवरेज केस बोला है ना। पवन आर यू देयर? पवन वही मैं बोल रहा हूं, फॉर वैल्यू ऑफ की इज इक्वल टू 90, अगर की का वैल्यू 90 है तो आपको आगे जाने की जरूरत नहीं है, यहां से ही नंबर ऑफ 3 नंबर ऑफ कंपैरिजन में हम लोग बोलेंगे की इज फाउंड। वी आर नॉट गोइंग इनटू द राइट सब एरे फॉर वैल्यू ऑफ की इज 90, हम आगे नहीं जा रहे। पवन इज दिस क्लियर? सो फॉर वैल्यू ऑफ की इज इक्वल टू 90 ओनली 1 2 एंड 3 तीन ही कंपैरिजन हो रहे हैं, ओनली 3 कंपैरिजन हो रहे हैं, हम लोग आगे नहीं जा रहे। सर ये आगे कब गए? फॉर वैल्यू ऑफ की इज इक्वल टू 100 के लिए आगे गए थे। इज दैट फाइन? ओके, सो दिस इज द बेस्ट केस, दिस इज एन एवरेज केस एंड दिस इज द वर्स्ट केस, राइट सर। लेकिन ये बेस्ट केस, एवरेज केस एंड वर्स्ट केस ये ऑकर कब होगा? ठीक है, अभी मैं आपको ये बता रहा हूँ विद हेल्प ऑफ डायग्राम। और आप लोगों को ट्री डेटा स्ट्रक्चर मालूम है? स्ट्रक्चर एटलीस्ट सुन के मालूम है सबको? ठीक है, एक काम करते हैं, जस्ट अ मिनट, आई विल शो यू डायग्राम. मैं आपको डायग्राम दिखाता हूँ एक, राइट, एंड विद द हेल्प ऑफ दैट डायग्राम, यस, with the help of that diagram, just a minute, with the help of that diagram, let us try to understand कि actually ये concept क्या होता है, right? Okay, can you see the diagram, guys? Can you see the diagram of tree? आपको पहले बताओ ट्री का डायग्राम हो रहा है क्या, दिख रहा है क्या आपको? Yes, right? Now in tree, can we say this is a root element? In tree data structure, can we say A is a root element, right? Or can we say this is a root position? Can we say this is a root position, right? Okay, now in tree data structure, element which is not having further child, जिस एलिमेंट को फर्दर चाइल्ड नहीं होते उसे क्या बोलते हैं? लीफ नोड और लीफ पोजीशन एलिमेंट, राइट? लीफ नोड और लीफ पोजीशन. सर, दिस नोड, is this node having child further? Is this node having child further? No. So can we refer this as a leaf node? Can we refer this as a leaf node? Yes. Sir, can we refer this as a leaf node? Yes. Sir, can we refer this as a leaf node? Yes. But sir, can we refer this as a leaf node? No, इसे leaf node नहीं बोलेंगे because it is having further child, right? So this position is called as non-leaf position. Sir, this position is called as non-leaf position, right? So in tree data structure, there are three possible positions: either root position or leaf position. And if any element is neither present at root position nor at leaf position, then it will be non-leaf position, in between. आपको ये तीन पोजीशन समझ में आया क्या? Have you understood these three positions, guys? Yes or no? Please reply me quickly. These three positions: root position, leaf position, non-leaf position, right? Okay, now if you look at this diagram, is it looking like a tree? Root position, अरे ये देखो, ये कौन सा पोजीशन है? ये रूट पोजीशन है, राइट? सो सर, कैन वी रेफर इट एज अ लीफ पोजीशन? यस. सर, ये कौन सा पोजीशन है? नॉन लीफ पोजीशन. ये कौन सा पोजीशन है? नॉन लीफ पोजीशन. सर, 20 इज एट नॉन लीफ पोजीशन, 10 इज एट लीफ पोजीशन, राइट? सो इसका मतलब इफ वैल्यू ऑफ इफ की इज फाउंड एट रूट पोजीशन, then it is considered as which case? If key is found at root position, this case is considered as best case. Understood? Right? Now, if key is found at a leaf position, 100, is 100 at leaf position? Yes. Sir, agar key ka value 40 to again. So if either key is found at a leaf position or key does not exist, so it will be a worst case, right? And if key is found at a non-leaf position, so 20, 80, 90, so it will be considered as, yes, an average case. Hello friends, have you understood this point? आपको ये point समझ में आया क्या? Right? तो मैंने यहाँ पे already लिख के रखा है. In best case, if the key is found in very first iteration at mid position, only one number of comparisons is required and it is considered as best case, right? So what is best case time complexity of binary search? Big omega of 1. So what is worst case? Worst case is order of log n, or we can say big O of log n, and average case big theta of log n. Sir, ये log n क्यों? Simple and small word, आपको भी इतने ही point याद रखने, right? Pay attention. So please remember this point. If any algorithm follows divide and conquer approach, then yes, we'll get time complexity in terms of, yes, in terms of log. ये याद रखो. तो अगर कोई एल्गोरिथम डिवाइड एंड कॉन्कर स्ट्रेटजी अप्रोच यूज कर रहा है, सो इन दैट विल गेट टाइम कम्प्लीट इन टर्म्स ऑफ लॉग, राइट? ठीक है, मैं आपको इसका एक सिंपल रीजन बताता हूँ. पे अटेंशन. सर, इफ साइज ऑफ एन एरे, अगर एरे का साइज है 1000, अरे हम लोग अभी रैंडमली देख रहे हैं, साइज है 1000, राइट? So in iteration number 1, pay attention, In iteration number 1, what we'll do? In iteration number 1, we divide array into 2 sub arrays. Sir, mid position क्या होगा? Mid position होगा 500 on an average. On an average, right? अरे हम लोग on an average randomly बात कर रहे हैं, don't calculate exactly, right? It means from 0 to 499. From 0 to 499 ये होगा left sub array. This is the mid position, and from 501 to 1000, this will be the right sub array. Hello friends, have you understood this? Right? ये समझ में आया आपको? Right? Now, then we'll compare value of key with mid position element. Sir, if key is not found, then in second iteration, don't you think either we'll search key into the left sub array or into the right sub array? Do you agree with this? Do you agree with this? Either we'll search into the left sub array or into the right sub array. It means after first iteration, don't you think after first iteration number of elements or search space कितना रह रहा है? Search space only n by, अरे because अगर total n का value initially अगर search space है n, अगर initially हम लोग 1000 element में search कर रहे हैं, so after first iteration कितने element में search करेंगे? Either into first half or into left sub array or into right sub array. It means search space gets reduced by half. Hello friends, do you agree with this? Right? Okay, let's say for example अगर हम left sub array में search कर रहे हैं, again in second iteration we'll calculate mid position, so 0 plus 499, right? So इसका मतलब क्या आएगा mid का value? Let's say randomly हम लोग 250 assume कर रहे हैं. अरे assume कर सकते हैं क्या यहाँ पे randomly 2, right? It means from 0 till 249 ये होगा left sub array, right? And from 251 till 500 ये होगा right sub array, right? It means again we are calculating mid position and we'll want to, if it is not found over here, then either we'll search key into left sub array or into right sub array. Do you agree with this? Right? It means after second iteration, if you want to go to third iteration, search space, yes, either we'll want to search into first 250 elements or second 250 elements. It means search space is again getting reduced by half. हेलो फ्रेंड्स, तो इसका मतलब सर सेकंड थर्ड इटरेशन के लिए कितने एलिमेंट रहेंगे? ओनली, यस, 250. अरे ओनली 250 ना? हाँ, सॉरी, आई एम सॉरी, हाँ यस 250 रहेंगे, राइट? इसका मतलब इफ यू गो टू द नेक्स्ट इटरेशन, अभी इन दिस इटरेशन, अरे इस इटरेशन में हम लोग क्या करेंगे? यस 0 to 290, मतलब यहाँ पे हमारा मिड क्या आएगा? 125 आएगा, राइट? इट मीन्स फ्रॉम 0 to 124 ये होगा लेफ्ट सब एरे, एंड 126 till 255, sorry 250, this will be what? Right sub array. Hello friends, are you getting what I'm saying? 249 randomly हम लोग ये अभी assume कर रहे हैं, right? It means yes n by 8, very good, n by 8. It means let me write it over here. So after first iteration or in first iteration search space कितना था? n था. In second iteration search space n by 2. In next iteration search space is n by 4. In third iteration search space, अरे आपको ये पैटर्न समझ में आ रहा है क्या? Right, n by 8 means can we say n is equal to, it is nothing but n divided by 2 raised to 0. What do we mean by 2 raised to 0? 2 raised to 0 means 1 ना, तो ये आंसर n ही आएगा ना, right? Here we can say, can we say n divided by 2 raised to 1, 2 raised to 1. Then here can we say n divided by 2 raised to 2. Here can we say n divided by 2 raised to 3. Hello friends, and so on, right? It means यहाँ पे ये कैसे reduce हो रहा है? Exponentially ना, exponentially, right? Okay, so exponential का inverse operation कौन सा होता है? Exponential operation का inverse operation logarithm, log होता है, right? Hence in divide and conquer approach as after every iteration, search space is getting reduced by half. मतलब पहले इटरेशन में n थे, सेकेंड इटरेशन में n by 2, थर्ड इटरेशन n by 3, फोर्थ इटरेशन n by 8, n by 2, n by 4, n by 8 and so on. तो सर ये हमें, that's why we are getting time complexity in terms of log, right? And hence if you go over here, so यहाँ पे हमें complexity क्या मिलेगा? Yes, ये तो सेम रहेगा big omega of 1, right? हाँ, लेकिन यहाँ पे we will get a time complexity as log n, log of n, log of n. Hello friends, have you understood this? तो प्लीज आपको सिर्फ यही याद रखना है, आपको सिर्फ ये टेबल याद रखना है, right? Now in out of these two, linear search and binary search, can you please tell me guys, n and log n अगर दोनों कंपैरिजन करेंगे तो दोनों में ग्रेटर कौन है? n is greater or yes, very good, and hence n is greater, and hence if you talk in terms of time complexity, yes, here we can say log n is efficient than n. Do you agree with this? Log n is efficient than n, right? Or here we can say order of 1 is efficient than order of log n. Obviously, अरे 1 is less than log n ना, n का वैल्यू कुछ भी हो सकता है, value of n may be anything, right? So order of 1 is efficient than order of log n, right? Order of log n is efficient than order of n, right? Then order of n is efficient than of n log n. जब आगे हम n log n यूज करेंगे तो ये याद रखो, right? उसके बाद n स्क्वायर. हेलो फ्रेंड्स, तो आपको ये टाइम कॉम्प्लेक्सिटी इन असेंडिंग ऑर्डर समझ में आया क्या? असेंडिंग ऑर्डर मतलब दिस इज मोस्ट इफिशिएंट, ये सबसे ज्यादा इफिशिएंट है. ऑर्डर ऑफ 1 बोलेंगे तो मोस्ट इफिशिएंट, देन ऑर्डर ऑफ लॉग n, एंड देन n log n, देन n स्क्वायर. इज दैट फाइन? पायल, मैंने आपको बताया है कि देखो यहाँ पे अगर आप देखोगी सर, आफ्टर एवरी इटरेशन सर्च स्पेस रिड्यूस कैसे हो रहा है? पायल, are you there? After every iteration, search space is getting reduced by half. n by 2, n by 4, n by 8. It means search space is getting reduced. कैसे हो रहा है reduce? Get reduced exponentially. कैसे हो रहा है reduce? Exponentially, right? तो एक्सपोनेंशियल ऑपरेशन का इनवर्स ऑपरेशन क्या होता है? लॉग ना, बिकॉज ये जो एक्सपोनेंशियल हो रहा है ये डिवीजन हो रहा है ना, तो बाय टेकिंग लॉग ऑन बोथ साइड, अगर आप लॉग लोगे तो हमें यहाँ पे आंसर क्या मिलेगा? लॉग एन मिलेगा ना. विल गेट टाइम कॉम्प्लेक्सिटी इन टर्म्स ऑफ लॉग, राइट? बिकॉज एक्सपोनेंशियल ऑपरेशन का इनवर्स ऑपरेशन क्या होता है? लॉग. सिर्फ इतना याद रखो, दैट्स इट, राइट? नो वन विल वांट टू आस्क यू, आपको सीकैट एग्जाम में कोई भी लॉग कैलकुलेट कैसे हुआ, कैसे आया, कोई नहीं पूछेगा आपको. आपको सिर्फ इतना याद रखना है कि लॉग इन. हाँ, लेकिन मैंने आपको आंसर बताया समझने के लिए कंसेप्चुअली. सर ये लॉग इन कब आता है? और when will get time in terms of log? Whenever there is a divide and conquer approach. Remember this. Whenever there is a divide and conquer approach, we'll get time complexity in terms of log. में exponentially क्या होता है? Search space gets reduced exponentially. Is that fine? Is that fine, friends? Right? Okay, now out of linear search and binary search, which one is efficient? Can you please tell me which one is efficient? Which one is efficient, linear or binary? Yes, binary search is efficient. Sir, लेकिन how we can decide it? So on which case, by considering which case? Best case, worst case or average case? By considering average case, right? So please remember one more point. When we compare, while comparing two algorithms at the time of deciding efficiency or which one is efficient? Which one is efficient? Which one is efficient? While comparing two algorithms at the time of deciding which one is efficient, yes, we need to consider, or we consider, yes, we consider an average case. An average case. Hello friends, is that fine? So by average case, which algorithm is efficient? Binary search efficient, and hence binary search is efficient than linear search. Is that fine friends? अरे आपको ये समझ में आया क्या? राइट? तो आपको सिर्फ ये याद रखना, आपको ये सिर्फ टेबल याद रखना है. That's it from CCAT point of view. No one will want to ask you to calculate. सर ये लॉग ही कैसे आया, कैलकुलेट करके बताओ. नो, आपको सिर्फ ये टेबल याद रखना है. That's it. Is that fine? And you have this logic. Have you understood this logic, friends? आपको ये logic समझ में आया क्या? Right? That is more than sufficient. That is more than sufficient. Right? Okay. Now here we have finished with searching algorithm. Now we move for sorting algorithm. And I told you हम लोग सिर्फ 3 algorithm देखने वाले हैं. राइट, बाकी एल्गोरिथम्स का मैं आपको यहाँ पे कॉम्प्लेक्सिटी बताऊंगा और आपको वो सिर्फ टेबल याद रखना है. दैट्स इट. राइट. ओके, सो फर्स्ट विल लर्न सिलेक्शन सॉर्ट. फर्स्ट विल लर्न सिलेक्शन सॉर्ट. राइट. ओके गाइस, पे अटेंशन कि उसका पहले लॉजिक क्या है. राइट. ओके, रीड केयरफुली विथ मी. इन दिस एल्गोरिथम, इन फर्स्ट इटरेशन, first position gets selected and element which is at selected position with all its next position elements. If selected position element found greater than any other position element, then swapping takes place. And in first iteration, smallest element gets settled at first position. In the second iteration, second position gets selected and element which is at selected position gets compared with all its next position elements. If selected position element found greater than any other position element, then swapping takes place. And in second iteration, second smallest element gets settled at second position, and so on. In maximum n-1 number of iterations, all array elements gets arranged in a sorted manner. Right? ठीक है, हमने लॉजिक पढ़ा. Now we will try to understand this logic with the help of example. Right? हमने अरे आपको डायग्राम दिख रहा है फ्रेंड्स? Can you see the diagram? Can you please tell me what is size of an array? Array का साइज कितना है बताओ मुझे यहाँ पे. Size of an array is 6. Right? Okay. Now in this algorithm, very first we need to select a position. So sir, in first iteration, can you please tell me what is the selected position? 0. It means ये position मतलब index, right? And after selection of position, we'll want to compare element which is at set position. So इसका मतलब position will want to remain fixed. Sir, उस position का element मतलब वो हो सकता है क्या change? Yes. So we'll want to compare element at selected position with all its next position elements. Right? Compare करेंगे. Right? So can we start position from 1? अरे हम position 1 से, yes. Right? Then we'll want to compare 30 and 20. Yes. Is element at selected position is greater than element at another position? Is element is 30 is greater than 20? Yes. और यहाँ पे क्या होगा? दोनों का swapping होगा. If element at selected position is greater than element at another position, then swapping takes place. तो यहाँ पे क्या होगा? Swapping होगा. Replace नहीं, swapping. Right? So 20 and 30 get swapped. Right? So selected position will remain fixed. Position plus plus. ये fix रहेगा first iteration के लिए. Right? Position plus plus. Now 20 or element which is at selected position gets compared with element at next position. 20 and 60 gets compared. Sir, is element at selected position is greater than element at position? No, and hence will be there. swapping होगा क्या? No, right? And hence no swapping will be there. Position plus plus. Go to the next element. Yes, now element which is at selected position 20 gets compared with element at position 20 and 50 gets compared. If element at selected position is greater than element at position, then swapping takes place. तो सर यहाँ पे swapping होगा क्या? No swapping will be there, right? And hence no swapping will be there. We can say position plus plus. We can say position plus plus. Go to the next position. Then element at selected position gets compared with element at position 20 gets compared with 10. Is element at selected position is greater than element position? Yes, and hence swapping takes place. यहाँ पे क्या होगा? दोनों का swapping होगा. 10 and 20 get swapped with each other. तो यहाँ पे आएगा 10, यहाँ पे रहेगा, right? 10 and 20 get swapped with each other, right? And we can say position plus plus. Next, element at selected position, interchange नहीं, swapping बोलते हैं उसे, swapping. Don't say interchange. हम लोग swapping का word use कर रहे हैं. Get swapped with each other, right? Okay, then what next? 10 gets compared with 40. So is it each swapping is required? No swapping is required because element at selected position is already smaller than element at position, right? And hence, yes, in first iteration, the smallest element gets settled at its appropriate position, that is at first position. Please check. उसके पोजीशन पे वो क्या हुआ है? फिक्स हुआ है, get settled. Hello friends, have you understood first iteration, right? Then we go to the next iteration, that is iteration number 2. Iteration number 2, right? Now in iteration number 2, for iteration number 2, value of selected position will be next position. Value of selected position will be next position. Next position होगा. Are you there, guys? Are you there with me? So in next iteration, position next होगा, and element which is at selected position gets compared with all its next position elements, right? Okay, 30 and 60 gets compared. So is there swapping is required? Is swapping is required? No, because element at selected position is already smaller than element at another position, and hence no swapping takes place. Position plus plus. Position plus plus. 30 gets compared with 50. Each swapping is required. Again, no swapping is required because element at selected position is already, yes, smaller than element at position. Are you with me? Right? And hence again, no need of swapping. No swapping is required. Go to the next iteration, right? Position plus plus. 30 gets compared with 20. 30 gets compared with 20. Yes. Is swapping is required? Yes, swapping is required because element which is at selected position is greater than element at another position, and hence यहाँ पे दोनों का क्या होगा? दोनों का यहाँ पे swapping होगा, and hence 30 and 20 get swapped with each other. 20 and 30 get swapped with each other. Then we can say position plus plus. Again, element at selected position 20 and 40 gets compared. So does swapping takes place? Again, no swapping is required, right? No swapping is required. And this iteration is over. And in this iteration, second smallest element gets settled at its appropriate position, at that second position. Array अभी तक sort हुआ है क्या? Array अभी तक sort हुआ है क्या? No, because maximum it takes how many number of iterations? Maximum it takes, yes, n minus 1 number of iterations, 5 number of iterations, n minus 1, right? And hence we go to the next iteration. Iteration number 3, right? Now for iteration number 3, value of selected position will be 2 and value of position will be what? 3, right? यहाँ से start होगा, next position start होगा, right? Why? Because we want to compare element which is at selected position only with its next position elements and not previous. हम लोग ये फिर से consider नहीं करेंगे, right? And hence, yes, what we'll do next in this iteration, 60 gets compared to 50. So does swapping takes place? Yes, because 11 select a position is greater than 11 at another position, and hence 50 and 60 gets swapped with each other, and we can say position plus plus. Then element at select a position gets compared with element at another position, 30, 50 and 30. Each swapping is required. Yes, swapping takes place over here. यहाँ पे swapping होगा, right? So copy and paste, swapping takes place. 30 and 50 get swapped with each other, and we can say position plus plus. We can say position plus plus. Now 30 and 40 gets compared. 30 and 40 gets compared. Each swapping is required. No, swapping is not required, right? Because element which is at selected position is already smaller than element at position, right? And hence, yes, no swapping is required. And in this iteration, next gets settled at its appropriate position. That is at third position. Hello friends, have you understood these many iterations so far? Right? Then we can go for next iteration. Iteration number, yes. Iteration number 4. Iteration number 4, right? Now in fourth iteration, value of select position will be what? 3. Right? And element at select position gets compared with its next position elements. So 60 and 50 gets compared. So does swapping is required? Yes, swapping takes place. Swapping takes place. So यहाँ पे swapping होगा, right? And hence 50 and 60 get swapped with each other. Position plus plus, right? Then 50 gets compared with 40. Each swapping is required. Yes, swapping is required. Again, swapping is required, and hence यहाँ पे 40 and 50 gets swapped with each other, right? And in this iteration, yes, next smallest element gets settled at its appropriate position, right? Now, sir, is array has been sorted? No, array अभी तक sort नहीं हुआ है. One more iteration is required, and hence we can say maximum. How many number of iterations takes place? n-1. That is, अगर आपका array का size है 6, so 6 minus 1, 5, right? So for this iteration, value of selected position will be 4, right? Then element at, तो सर दोनों का कंपेरिजन होगा यहाँ पे. each swapping takes place, swapping होगा, right? So 50 and 60 get swapped with each other, right? And in this iteration, next smallest element gets fixed, right? So again, is there any need to go to next iteration? No, because there's only one element left at one position. So ये उसका appropriate position है. No need to go to next iteration. And hence maximum, how many iterations are sufficient? Maximum, how many number of iterations are sufficient? Yes, n-1 number of iterations are sufficient. n-1. Hello friends, have you understood this logic? Have you understood this? आपको ये selection sort का logic समझ में आया क्या? Right? So same logic I have written over here. यहाँ पे वही logic लिखा है. Is that fine? Okay. Now let me tell you very quickly, just to get an idea, right? कि sir इसका complexity कैसे मिलता है, right? Okay. In first iteration, how many number of comparisons takes place? Quickly. In first iteration, कितने कंपैरिजन हो रहे हैं? 1, 2, 3, 4, 5. In second iteration, 1, 2, 3, 4. In third iteration, 1, 2, 3. Right? It means, can we say in first iteration, n-1 number of comparisons takes place? Hello friends, do you agree with this? In first iteration, n-1 number of comparisons. In second iteration, n-2 number of comparisons. In third iteration, n-3 number of comparisons. In fourth iteration, n-4 number of comparisons, and so on. Right? It means here we can say in iteration number 1, Yes, number of comparisons is equal to, yes, n minus 1. That is, can we say order of n minus 1 number of comparisons takes place in first iteration? In first iteration, can we say order of n minus 1 number of comparisons takes place? Right? Now, we know that running time, if running time is having any substantive constant, it can be neglected. So it comes out to be how much? N minus 1 comes out to be order of n. Do you agree with this? Hello, friends. Do you agree with this? Right? Now, in second iteration, in iteration number 2, how many number of comparisons takes place? N minus 2. That is, can we say order of n minus 2 number of comparisons are there? Again, it is a substantive constant. It can be neglected. And again, can we say that in second iteration as well? N numbers, right? And so on. And so on. Right? N minus 3. So यहाँ पे भी can we say n number of comparisons again? Yes. So ऐसे total कितने iterations हो रहे हैं? Maximum, how many number of iterations? In general, n minus 1. In general, n minus 1 number of iterations. Right? So इसका मतलब यहाँ पे भी हम लोग क्या बोलेंगे? Can we say order of n only? Right? And hence total number of comparisons. Total number of comparisons is equal to n into n minus 1. अरे अगर हर एक इटरेशन में n number of comparisons हो रहे हैं, if in every iteration n number of comparisons takes place, तो ऐसे कितने iterations हो रहे हैं? n minus 1. So can we say total number of comparisons are n into n minus 1? Hello friends, n into n minus 1, right? That will be n square minus n. Can we say like this? N square minus n, right? It means we can say order of n square minus n. इतने number of क्या हो रहे हैं? Comparisons हो रहे हैं, right? Now you need to remember one rule. Remember मतलब आपको rule नहीं पूछेगा, आपको कोई rule नहीं पूछेंगे, लेकिन ये rule याद रखो और समझो, right? Yes, rule say that if running time of an algorithm is having any polynomial, then yes, in time complexity or in its time complexity, in its only leading term gets considered, right? So can you please tell me, guys, is this a polynomial? Right? And which is the leading term? It means term with having maximum power, right? N square, right? And hence here we can say n square इसका रनिंग टाइम है. सर अगर ऐसे होता तो if let's say n cube plus n minus 5. Now in this polynomial, can you please tell me which is the leading term? Or let's say एक काम करते हैं यहाँ पे, और n square plus 5n minus 5. Sir, is this a polynomial? Yes, this is a polynomial. So in this polynomial, which is the leading term? N cube is a leading term, and hence in such case n cube will be what? Running time, or we can say time complexity. तो उसके टाइम कॉम्प्लेक्सिटी में सिर्फ लीडिंग टर्म कंसीडर किया जाता है. ये क्या रूल है? प्लीज रिमेंबर दिस. यस, इन सिलेक्शन एल्गोरिथम, यस, यहाँ पे हमें कॉम्प्लेक्सिटी क्या मिलेगा? We'll get time complexity as n square, right? n square. अरे why n square? Because देखो यहाँ पे n square ना, n square minus n, which comes out to be what? Order of n square only. Hello friends, तो आपको ये रनिंग टाइम समझ में आया क्या? Yes. And in all cases, it means in all cases its complexity will be n square only. N square only. Hello friends, because even, pay attention, even array elements are already sorted, then only it will take same number of comparisons, same number of iterations. अगर array already भी अगर sorted होगा, then only it will take same number of iterations and same number of comparisons, and hence in all possible cases, magnitudes of time complexities are same in selection sort. Hello friends, is this fine? क्या आपको समझ में आया क्या? सिलेक्शन सॉर्ट, राइट? तो सर सिलेक्शन सॉर्ट का बेस्ट केस टाइम कॉम्प्लेक्सिटी इज ओमेगा ऑफ एन स्क्वायर, बिग ओमेगा ऑफ एन स्क्वायर. वर्स्ट केस इज बिग OH ऑफ एन स्क्वायर, एंड एवरेज केस इज बिग थीटा ऑफ एन स्क्वायर. So what about magnitude? N square, n square, n square. It means magnitudes of time complexities in all cases is same in selection sort. Is that fine? Hello friends, is that fine? तो मैंने यहाँ पे देखो टेबल में ये लिखा है, right? So this is what all about selection sort. To the logic of selection sort, friends. आपको ये logic समझ में आया क्या? Paperwork. Have you understood paperwork? Have you understood concept of selection sort? Right? और आपको सिर्फ ये paperwork exam point of view, CCAT point of view, only this paperwork and this is important. आपको सिर्फ ये याद रखना है. That's it. Is that fine? From exam point of view, no one will want to ask you to write a program. No one will want to ask you to prove कि how its time complexity is this much. लेकिन मैंने आपके इंफॉर्मेशन के लिए जस्ट टू गेट एन आइडिया मैंने आपको ये बताया यहाँ पे. इज दैट फाइन? सो कैन वी मूव टू द नेक्स्ट एल्गोरिथम, दैट इज बबल सॉर्ट. कैन वी मूव टू द नेक्स्ट एल्गोरिथम, दैट इज बबल सॉर्ट. हेलो फ्रेंड्स, आर यू विथ मी? आर यू देयर? राइट? सो वी आर मूविंग टू द नेक्स्ट बबल सॉर्ट. राइट? नाउ अगेन इन बबल सॉर्ट, if you read logic carefully, pay attention. In this algorithm, in every iteration, elements which are at two consecutive positions gets compared. If they are already in order, so what do you mean by already in order? Then no need of swapping between them. But if they are not in order, it means that is if previous position element is greater than its next position element. Right? Okay. By default, when we say we sort elements, by default, in which order we sort elements, ascending or descending? By default, ascending order. Right? It means let's say 10, 20, 30, 40, 50. Right? Now, can we say this is the previous position element and this is next position element? If we consider these elements which are at two consecutive position, right? So this is element, this is next position element. Now, in this case, if previous position element should be smaller than its next position element. So not only for this for this as well, previous position element should be smaller than next position element. For this pair as well, previous position element should be less than. Hello friends, then only we can say they are in order. Do you agree with this? Right? Sir, अगर ये order में नहीं होंगे तो फिर क्या करेंगे? Swapping करेंगे. Right? If they are not in order, then we'll swap them. Right? Okay, we'll try to understand this with the help of example. Pay attention. So, can you please guys tell me what is the size of an array? Reply me quickly. What is size of an array? Size of an array is 6. Right? So, we start in first iteration. हम लोग first iteration start करते हैं. Right? So, position is 0. So, if position is next position, position plus 1. How we can access his next position? Position plus 1, right? Then we'll want to compare these two elements, this pair. So is this pair is in order? Is previous position element is greater, is smaller than or less than its next position element? No, this pair is not in order, and hence we'll want to swap them. हम क्या करेंगे? उसे swap करेंगे. We'll want to swap them. It means 20 and 30 get swapped with each other, right? Then we'll want to compare next pair. We'll compare next pair. 0, 1, 1, 2, 30, 60. Sir, is this pair is in order? Yes, this pair is already in order. So is there a need of swapping? No, there is no need of swapping. And hence we go to the next position. Position plus plus. So if value of position is 2, will be 3. We're going to compare next pair. Sir, is this pair is in order? No, this pair is not in order, because if you look at carefully, previous position element is greater than its next position element, and hence यहाँ पे क्या होगा? Swapping takes place. Swapping takes place, right? And hence 50 and 60 get swapped with each other, right? And we'll say position plus plus. So next pair gets checked, gets compared, right? Okay, so is this pair is in order? Is this pair in order? No, this pair is not in order, and hence swapping takes place. Swapping takes place. So 10 and 60 get swapped, and we can say position plus plus. We can say position plus plus, right? Then 60 and 40, this pair gets compared. At 2 consecutive positions gets compared with each other. If they are in order, no need of swapping. If they are not in order, swapping takes place. So यहाँ पे swapping होगा, right? And hence 60 and 40 get swapped with each other, right? 40 and 60 get swapped, right? And in first iteration, largest element gets settled at its appropriate position, that is at last position. Please check guys, 60 यहाँ पे क्या हुआ, set fix हुआ, right? In first iteration. Now we go to the next iteration, second iteration. We go to second iteration. Again, in iteration number 2, we'll apply same logic. We'll apply same logic, right? It means we're going to compare elements which are at 2 consecutive positions. So is this pair is in order? Yes, this pair is in order. So no need of sub. Hence, position plus plus. We can go to the next position. Next pair gets compared. 30-50. Is this pair is in order? Yes, this pair is as well is in already in order. No need of swapping. Go to the next position. Position plus plus. Next pair gets compared. So is this pair is in order? No, this pair is not in order, and hence swapping takes place. 50 and 10 get swapped with each other. 50. I'm sorry. 50 and 10 get swapped with each other, right? 10 and 50 get swapped with each other, and position plus plus. Now 50 and 40 gets compared. Yes, is this pair is in order? No, this pair is not in order, and hence swap. And in this iteration, yes, in this iteration, next largest element gets settled at its fixed position, that is at second last position. Hello friends, are you getting how the largest element are getting settled at last position after every iteration, right? So in next iteration, we'll go to the next iteration. In next iteration, yes, iteration number 3. In next iteration, again we'll apply same logic. Elements which are at 2 consecutive position gets compared. If they are in order, no need of swapping. If they are not in order, swapping takes place. So they are already in order, no need of swapping. And hence we can say position plus plus. So next pair gets compared. Is this pair is in order? No, this pair is not in order. Hence swapping takes place. Swapping takes place. So 10 and 30 get swapped with each other. We can say position plus plus. 30 and 40 gets compared. Is this pair is in order? Yes, this pair is already in order. So no need of swapping, right? And hence in this iteration, next largest element gets settled at its appropriate position, that is at third last position, right? And now we can go to the next iteration. Next iteration, that is iteration number 4. Iteration number 4, right? In iteration number 4, again, we apply same logic. Elements which are at 2 consecutive position gets compared. So does swapping is required? Is swapping required? Yes. Does swapping takes place? Yes, swapping यहाँ पे होगा, right? And hence 10 and 12 swapped with each other, position plus plus. Then 20 and 30 gets compared. Is this pair is in order? Yes, this pair is already in order. No need of swapping, right? And hence, in this iteration, next largest element gets settled at its appropriate position. Hello friends, are you with me? Right? And finally, control go to the next iteration. Finally, control go to the next iteration. That is iteration number 5. Right? Now in iteration number 5, only one pair is left, na? अरे एक ही pair left है ना? Sir, is this in order? Yes, this is already in order. So no need of swapping. And hence in this iteration, next largest element gets settled at its appropriate position, right? And finally, all array elements get sorted, gets arranged in a sorted manner. Hello friends, have you understood the logic of bubble sort? आपको bubble sort समझ में आया क्या? Have you understood bubble sort? Right? Sir, bubble means what? Why it is named as bubble? Because in this algorithm, yes, let's say for example, if you are taking a water in a bucket, right, and if you insert objects into it, so don't you think heaviest elements or heaviest objects will get settled at the bottom first, and lighter element gets floated like bubbles. Bubble क्या होते हैं? Float होते हैं, right? And heaviest element gets settled at the bottom. Similarly, in this algorithm, as heaviest element gets settled first, then second largest element gets settled, then third largest element gets settled, and we can say lighter elements gets floated like bubble, right? And hence this algorithm is named bubble sort. Hello friends, have you understood why it is named as bubble sort and why it is named as selection sort? Because in this algorithm, element which is at selected position gets compared. मतलब यहाँ पे position select होता है in every iteration. An element at selected position gets compared with all its remaining position elements, and hence it is named as selection sort. Have you understood the difference between selection sort and bubble sort? Logic, right? Here also passes n-1. Yes. यहाँ पे भी maximum how many number of iterations are required? Pawan, maximum how many number of iterations are required? Maximum n-1 number of iterations are required, and hence its worst case time complexity. अरे इसका जो worst case है वो क्या है? Its worst is n square is n square. Hello friends, if you go by algorithm, have you understood so far? अरे आपको यहाँ तक समझ में आया क्या? Right? Now pay attention. But sir, bubble sort can be implemented. Pay attention. Can be implemented at implementation level. Can be implemented efficiently with the help of logic of flag. Sir, वो कैसे? Pay attention. Logic of flag मतलब whether we need to go next or not. अरे flag का मतलब मालूम है ना आपको? Flag जो flag होता है, right? ट्रेन जाता है तो उनको अगर flag दिखा है तो ट्रेन रुकती है. It depends upon the color of the flag or signal, right? Red signal indicates you have to stop. Flag means indication, right? Okay. Now pay attention. ये कैसे? Pay attention. Let's say for example we are having 6 elements with us, and if array is already sorted, so bubble sort can be implemented efficiently with the logic of flag for already sorted input sequence. वो कैसे? Please check. Pay attention. Sir, in bubble sort algorithm, what logic says? In bubble sort algorithm, what logic says, guys? In bubble sort algorithm, logic says we are comparing elements which are at 2 consecutive positions, right? So let's say for example we are in first iteration. In first iteration we compare elements which are at 2 consecutive first 10 20. Sir, is this pair is in order? no need of swapping. Then we compare next pair. Is this pair is in order? Hello friends, please reply me quickly. Is this pair is in order? Yes, this pair is also in order. Next we compare this pair. Is this pair is in order? Yes. Then we compare this pair. Is this pair is in order? Yes. Sir, is this pair is in order? Yes. Are you getting what I'm saying, guys? It means if all pairs are in order, what it indicates? Array elements are already arranged, or array is already. Hello friends, array is already sorted. Do you agree with this? अरे अगर सारे के सारे pair, if all the pairs are in order, then what it means? It means array is already sorted. So is it necessary to go to next iteration? अरे next iteration में जाने की जरूरत है क्या? No, there is no need to go to next iteration. And hence यहाँ पे कुछ तो flag maintain करेंगे, right? Let's say for example initially flag का value है true. Let's say initially value of flag is true, right? Why true? Because at least एक iteration तो होना ही चाहिए ना. हेलो फ्रेंड्स, एग्री विद दिस? मिनिमम एक इटरेशन होना चाहिए ना, मिनिमम एक इटरेशन होना चाहिए टू चेक वेदर ऑल पेयर्स आर इन ऑर्डर और नॉट. एंड हेंस इनिशियली वो ट्रू किया है, राइट? एंड एज सून एज कंट्रोल कम इनसाइड फर्स्ट इटरेशन, तो उसे क्या करेंगे? फॉल्स करेंगे. आर यू गेटिंग व्हाट आई एम सेइंग? राइट नाउ फॉल्स करने के बाद सर वैल्यू ऑफ फ्लैग विल बिकम्स ट्रू ओनली इफ, वैल्यू ऑफ फ्लैग विल बिकम्स ट्रू ओनली इफ array elements are not arranged in a sorted manner. Sir, agar if all pairs are in order, it will remain false. So agar flag ka value false hai, matlab second, no need to go to next iteration. So value of flag will remain becomes true only if any single pair is not in order. Sir, agar सारे के सारे pairs order में है तो flag का value false ही रहेगा and control will never go into the next iteration. Hello friends, तो इस flag को indication use करेंगे वहां पे, just like an indicator, right? It means, don't you think this is the best case? Hello friends, because if array elements are already sorted, then how many number of iterations takes place? Only one iteration. Sir, in one iteration, how many number of comparisons takes place? In one iteration, one comparison, second comparison, third comparison, fourth comparison, and fifth comparison. It means, can we say n minus 1? So in best case, yes, total in one iteration, only n minus 1 number of comparisons takes place. Hello friends, do you agree with this? Do you agree with this? And hence, yes, running time in best case will be equal to what? Yes, order of n minus 1 in best case. That will be equal to, yes, n minus 1. If running time of an algorithm is having any subtractive constant, then it can be neglected and it comes out to be what? Order of n. हेलो फ्रेंड्स, तो आपको ये बेस्ट केस समझ में आया क्या? राइट? एंड हेंस कैन वी से ओवर बिग ओमेगा ऑफ n, बिग ओमेगा ऑफ n. हाँ, बट बबल सॉर्ट इट कैन बी अचीव्ड ओनली एट एन इम्प्लीमेंट, राइट? सो बबल सॉर्ट कैन बी इम्प्लीमेंटेड efficiently, yes, at bubble sort can be implemented efficiently, right, for already sorted input sequence. Hello friends, is this clear to all of you? अरे आपको समझ में आया क्या? First point, right? Bubble sort can be implemented efficiently for already sorted input sequence, but by design, is it efficient? By design, is it efficient? No. By design, bubble sort is not efficient. Not efficient for already input sequence, but yes, but it can be implemented. अगर मुझे ऐसे लिखना चाहिए था, right? ठीक है, एक काम करता हूं मैं यहां से cut it from here and let me paste it. Okay, I'm sorry, but it can be implemented. Just a minute. But it can be implemented efficiently by using logic of a flag. So at an implementation level उसे efficient कर सकते हैं हम लोग. Is that fine, friends? अरे आपको ये पॉइंट समझ में आया, राइट? सर तो फिर दोनों में efficient कौन सा है? Which one is efficient? Selection sort or bubble sort? Which one is efficient? Selection sort or bubble sort? Which algorithm is efficient? Selection sort or bubble sort? No, friends, please remember this. I told you, whenever we compare two algorithms for deciding their time complexity, yes, we need to consider their average case time complexities. Have you understood this, friends? We need to consider their average case time complexities, and average case time complexities of both algorithms are same, right? And hence सिर्फ दोनों का टाइम कम्युनिटी क्या है, सेम है, right? So we cannot say bubble sort is efficient than selection sort. Is this understood, friends? आपको ये समझ में आया क्या, right? Are same efficient wise. Hello guys, efficiency wise both are same because उन दोनों का average case is what? Yes, efficiency wise both are same. हाँ, लेकिन एट एन इम्प्लीमेंटेशन लेवल, अरे हम लोग एल्गोरिथम बात करेंगे तो दोनों सेम है इफिशिएंसी. एट एन प्लीज लिसन केयरफुली, एट एल्गोरिथम लेवल व्हेन वी कंपेयर एल्गोरिथम्स फॉर डिसाइडिंग देयर इफिशिएंसी, तो हम लोग क्या करते हैं, विच केस वी कंसीडर, which case we consider? Average case, right? Now what is average case of selection sort? Average case time of selection sort is n square. What is average case of bubble sort? N square. So n square मतलब सेम है ना दोनों का average case at algorithm level, design level. Bubble sort can be implemented efficiently, मतलब at an implementation level it can become efficient. सर इसका मतलब वो स्पेशल केस में ही है ना, सिर्फ बेस्ट केस में. आर यू गेटिंग व्हाट आई एम सेइंग? एंड हेंस इफिशिएंसी वाइज, एल्गोरिथम वाइज दोनों का कॉम्प्लेक्सिटी क्या है, सेम है. इज दिस क्लियर? इज दिस क्लियर टू ऑल ऑफ यू, राइट? एंड हेंस हियर वी कैन राइट बबल सॉर्ट एंड सिलेक्शन सॉर्ट आर नॉट efficient for larger input size array. Hello friends, do you agree with this? Sir, अगर array का size 1000 है, so 1000 into 1000 number of comparisons, there is n square, right? And hence bubble sort and selection sort are not efficient for array. Is this clear so far? यहां तक सबको समझ में आया क्या? Hello friends, please let me know anyone having any doubt quickly. Is anyone having any doubt still? Am I going fast, friends? मैं फास्ट जा रहा हूं क्या? थोड़ा सा फास्ट जाना ही पड़ेगा बिकॉज इट इज यू पीपल हैव जॉइन क्रैश कोर्स. इतना तो स्पीड हमें रखना ही पड़ेगा. अगर आपने क्रैश कोर्स ज्वाइन किया है, in 10 hours we need to complete as maximum as possible. We need to cover as maximum as possible in 10 hours, right? तो इतना स्पीड तो हमें लगेगा ही, right? So please your concentration increase. आपको थोड़ा सा concentration लगाना पड़ेगा. And if you are having any doubts, please ask me. Yes, it is a request to all of you guys. So far, Shall we continue with the next algorithm? We continue with the next algorithm, right? And next algorithm is insertion sort. Next algorithm is insertion sort, right? Now, if you talk about insertion sort, देखो मैंने यहाँ पे लिखा है, right? Insertion sort. In this algorithm, pay attention. Do people know playing cards? अरे आपको playing card मालूम है क्या? How we arrange cards in our left hand in a sorted manner, right? So total how many cards are there? मतलब किसी एक कितने 11 कार्ड होते हैं ना, हमें 11 कार्ड्स हमें सॉर्ट करने होते हैं, राइट? ओके, हमें सेम लॉजिक यूज करना है. सो इनिशियली पे अटेंशन, लेकिन हमारे पास 11 कार्ड होते हैं ना, एक के पास 11 या 13 ऐसे कुछ तो होते हैं, ठीक है? वॉट एवर लेट्स से 10 कार्ड्स आर देयर, पे अटेंशन, लेट्स से, right? And what we need to do, we need to arrange those 10 cards in our left hand in a sorted manner. Are you with me, friends? So initially क्या होगा? Initially we are having one card in our left hand and remaining n-1 number of cards kept on the desk. एक कार्ड हमारे हाथ में है और बाकी के n-1, मतलब अगर हमने if we assume n is 10, so out of 10 one card is in our left hand initially and n-1, that is 9 number of cards are there onto the desk, right? Then what we does, we first we pick one card in our right hand from desk. Right hand से हम एक card pick करते in our right hand. So can be referred, whichever card we pick in our right hand, we will want to refer it as a key card. So what we does usually, we pick one card in our right, find its position in our left hand. हमारे left hand में उसका appropriate position find करते हैं, and as soon as we found its appropriate position by comparing elements which are already in our left hand from right to left, and we insert it at that position or at its appropriate position. Then in second iteration we pick next card in our right hand. हम अभी दूसरा कार्ड क्या करते हैं, राइट हैंड में पिक करते हैं. So after picking next card in our right hand, yes, again we find its appropriate position in our left hand by comparing value of that card in our right hand with all elements in our left hand from right to left. Hello friends, can you visualize this? Hello guys, can you people visualize this? आपको ये लॉजिक समझ में आया क्या? प्लेइंग कार्ड्स का कैसे सॉर्ट करते हैं? Yes or no? Please reply me. If no, then only fine. You can reply no as well, because I'm going to tell you with the help of example. I'm going to teach you with the help of example, right? अगर समझ में नहीं आया होगा तो भी चलेगा, don't worry, right? ये रिपीट होगा बाद में फिर से. Sajjan, don't worry about it, right? Okay. Now in insertion sort, pay attention. हाँ, अभी attention दो. So what is size of an array, friends? Size of an array is 8. Please, Atharva, check carefully. Size of array is 8. It means total how many number of elements are there? 8 number of elements are there, right? So let's say initially this 50, this element is in our left hand, and remaining n-1 number of elements kept on the desk. Please, हम लोग ये assume कर रहे हैं, visualization is important. Initially one element is in our left hand and n-1 number of elements kept onto the desk. हमने desk के ऊपर रखे. So what we'll do, we'll pick in first iteration, we'll pick first element and we'll want to refer it as a key. So what will be the value of key, guys? We'll pick first element. So value of key will be what? 80. अरे हम element pick कर रहे हैं, element. So element का value कितना है? 80, right? It means if we say this as I, अगर हम यहाँ से start करेंगे indexing, if we say value of I is 1, then value of key is what? ARR of I is 80, right? Then we, after picking key, we need to find its appropriate position. हमें क्या करना है? We need to find an appropriate position of key in our left hand, right? So in our left hand currently, how many number of elements are there? Yes, in our left hand, how many number of elements are there? Yes, only one element is there. So and we need to make sure elements which are in our left hand must present in a sorted manner. वो क्या होने चाहिए? Must be present in a sorted manner, right? सर अगर सिर्फ एक ही एलिमेंट तो वो सॉर्टेड है क्या? Yes, it is already in a sorted manner, right? Okay, now we start comparing that element key with elements which are in our left hand from right to left. अरे कौन से डायरेक्शन में कंपैरिजन स्टार्ट करेंगे? In which direction we start comparing? Yes, in this direction, from right to left. Hello friends, right? Okay, then value of key 80 gets compared with 50. Is 80 is less than 50? Is 80 is less than 50? No. And hence, so where will be the position of the key? Before 50 or after 50? Where will be the position 50 or after 50? Yes, and hence we need to insert key after 50. Are you getting what I'm saying, friends? तो हमें की को इंसर्ट कहां पे करना है? We need to insert key after 50, right? And hence after 50 we'll want to insert key. 50 के बाद हम की को क्या करेंगे? इंसर्ट करेंगे in first iteration. Hello friends, have you understood first iteration? आपको पहले इटरेशन समझ में आया? Now in first iteration, after first iteration, how many number of elements are there in our left hand now? 2 elements. Sir, are these elements have been arranged in a sorted manner? वो element sorted है क्या? Yes, right? Now we can go to the next iteration. It means we want to pick next element from the desk. अरे ये elements desk पे रखे, so we'll want to pick next element from the desk, right? Value of key now. If value of I is 2, then value at I, value of key is what? 30. तो key का value क्या है हमारा? 30. Sir, after picking key, pay attention, logic repeat हो रहा है, so concentrate. After picking key element in our right hand, we'll want to compare or we'll want to find appropriate position of key in a left hand, in our left hand, and wherever we find its appropriate position, we'll want to insert it. So लेकिन उसका पोजीशन फाइंड करने के लिए हमें क्या करना पड़ेगा? We need to compare value of key with each elements which are in our left hand from right to left, and as soon as we found the position, appropriate position of key, we'll insert key at that position, right? Okay, pay attention. So we pick key in our right hand, that is 30, right? We compare with 80. अरे हम स्टार्ट कहां से करेंगे ना? राइट टू लेफ्ट. सो वी स्टार्ट फ्रॉम J. यहां से I-1 से स्टार्ट करेंगे, राइट? सो वैल्यू ऑफ की इज व्हाट? 30. Is 30 is less than 80? Is 30 is less than 80? Yes, and hence key should be present before 80. Key should present before 80, right? Sir, लेकिन before 80 elements है क्या? Yes, and hence what we can do? We can shift 80 towards right hand side by one position. हम लोग 80 को शिफ्ट करेंगे, will shift 80 towards right hand side by one position. So लेकिन वहां का 30 ओवरराइड हुआ. 80 शिफ्ट किया हमने राइट हैंड साइड को, so वहां का 30 ओवरराइड हुआ. Don't worry, this 30 we have already stored into the key as a key, right? Okay, now we'll say J minus minus. It means now we need to compare value of key with its previous position element, right? 50 के साथ कंपेयर करेंगे. Is 30 is less than 50? Is 30 is less than 50? Yes, and hence 50 should be present. Sorry, 30 should present before 50 or after 50? Before 50, right? And hence we need to shift 50 as well towards right hand side by one position. इसलिए हम 50 को भी क्या करेंगे? शिफ्ट करेंगे, right? And at this position we'll want to insert key. और हम लोग यहाँ पे क्या करेंगे? की इंसर्ट करेंगे. Hello friends, have you understood this? Right? So we have inserted in this iteration, we have inserted 30 key at its appropriate position, right? Next iteration, अरे अभी तक पूरा array sort हुआ है क्या? No, only 3 elements are there now in our left hand. In our left hand only, how many number of elements are there? Only 3 number of elements are there, right? Till array is not yet sorted, right? So we go to the next iteration. Now for next iteration, can you please tell me what will be the value of key? Value of key will be value of key will be 60, right? Then after picking key in our right hand, we need to find its appropriate position in our left hand by comparing elements which are in the left hand from right to left, one by one. And hence we compare 60 first with 80. Each 60 is less than 80. Yes, and hence 60 should present before 80. तो सर हमें 80 को क्या करना है? We need to shift 80 towards right hand side by one position, right? And we say j minus minus, or we can say we are moving to its previous position. Again, we need to compare 60 with 50. Each 60 is less than 50. Each 60 is less than 50. No, and hence don't you think guys 60 should be inserted after 50 na? 50 के बाद होना चाहिए ना insert उससे. So what is the position of 50? 1. Say at jth plus 1 position insert key. मतलब 50 का जो next position है वहां पे क्या insert होगा? 60 insert होगा. So 60 should get inserted at jth plus 1 position. मतलब यहाँ पे it means in this iteration we inserted a key at its appropriate position. Now total how many number of elements are there in our left hand? Total how many number of elements are there in the left hand? 4. Sir, have they arranged in a sorted manner? वो sorted manner में arrange हुए हैं क्या? Yes, right? Sir, पूरा array sort हुआ है क्या अभी तक? No, whole array is not yet sorted. Sir, maximum how many number of iterations it will take? It will take n minus 1 number of iterations, right? And hence we go to the next iteration. I plus plus. So for value of I is equal to 4, what will be the value of key? Value of key will be equal to 70. Now after picking key, pay attention, हर एक iteration में repeat कर रहा हूं, so listen carefully. After picking key, we need to find its appropriate position in left hand and we can insert it at that position, right? So but how we can find position of key? If you want to find position of key, we need to compare value of key with elements which are in our left hand from right to left. And while comparing, if we found, as soon as we found its position, appropriate position, we'll want to insert it at that position, right? Okay, so how we can start comparing from right to left? मतलब right to left यहाँ से start करेंगे. So 70 first gets compared with 80. Each 70 is less than 80. Each 70 is less than 80. Yes, and hence 70 should get inserted before 80. सर लेकिन डायरेक्टली इंसर्ट कर सकते हैं क्या? नो. Why? Because इसके पहले भी एलिमेंट हो सकता है ना, right? And hence we need to right hand side by one position and we'll say j minus minus. Again compare 70 with 60. Yes, 70 gets compared. Is 70 is less than 60? No, and hence key should be inserted after 60. After 60 के बाद. So इसका मतलब 60 is at which position? Jth position, that is the second position. So at jth plus 1 position 70 should get inserted. Hello friends, are you getting? So jth plus 1 position यहाँ पे क्या insert होगा? 70 insert होगा. Hello guys, have you understood this? So after this iteration, in our left hand, total how many number of elements are there? 5 number of elements are there. Sir, have they arranged in a sorted manner? Yes. So we need to make sure after every iteration, whichever elements are there in our left hand must be there in a sorted manner, right? Now can we go to the next iteration? We can go to the next iteration. So for value of I is equal to 5, value of key will be equal to what? Value of key will be equal to 20. So we pick 20 in our right hand. We pick 20 in our right hand. ऐसे visualize करो. So हमने 20 right hand में pick किया है, and these elements are there in our left hand. So we need to find its appropriate position, and wherever we found its appropriate position, we'll going to insert it. तो ये position find करने के लिए we start comparing elements which are in our left hand from right to left. इस direction में comparing start करेंगे. So we'll start comparing. 20 gets compared with 80. Is a 20 is less than 80? Yes, and hence we need to shift 80 towards right hand side because 20 80 के पहले होगा, right? Then we can say j plus plus. Again we compare 20 with 70. Is a 20 is less than 70? Yes, and hence we need to shift 70 as well towards right hand side. J minus minus. Again, compare 20 with 60. Is 20 is less than 60? Yes, and hence 60 as well should get shifted towards right hand side by one position. J minus minus. 20 gets compared with 50. Is 20 is less than 50? Yes, value of key is less than 50, and hence we need to shift 50 as well towards right hand side by one position, and we'll say J minus minus. Again, 20 gets compared with 30. Is value of key is less than 30? Yes, and hence 30 as well should get shifted towards right hand side by one position. J minus minus. So but J का वैल्यू क्या होगा फिर वहां पे? Value of J will become what? -1. Sir, is -1 the valid position? No, -1 is not valid position, and hence now we can insert key at J plus 1 position. -1 plus 1, -1 plus 1, 0, and hence at 0th position value of key will get inserted. Please check. So in this iteration we inserted key at its appropriate position. Hello guys, now how many number of elements are there in our left hand? 6 number of elements are there in our left hand. Sir, have they arranged in a sorted manner? Yes, they have arranged in a sorted manner. Are you getting what I'm saying, guys? Right? Now, sir, लेकिन पूरा array sort हुआ है क्या? No. And hence we can go to the next iteration, I plus plus. Now for next iteration, value of key will be what? 10. Value of key will be 10. Again, after picking key in our right hand, we need to find its appropriate position in our left hand. And as soon as we found its appropriate position, we want to insert it at that position. Right? So for that, we start comparing from right to left. अरे जितने एलिमेंट हमारे लेफ्ट हैंड में राइट टू लेफ्ट कंपेयर करेंगे. So 10 gets compared with 80 first. Is 10 is less than 80? Yes, and hence we need to shift 80 towards right hand side by one position. J minus minus. J minus minus. Again compare value of key 10. Is it less than 70? Is it less than 70? Yes, and hence we need to shift 70 as well towards right hand side by one position. Say J minus minus. Again compare value of key 10. Is it less than 60? Yes, so 60 as well shifted towards right hand side by one position. J minus minus. 10 gets compared to 50. Is value of key is less than 50? Yes, so sir 50 भी क्या होगा? 50 भी shift होगा towards right hand side by one position. Again compare 10 with 30. Is 10 is less than 30? Yes, and hence 30 as well gets shifted towards by one position. J minus minus. Again compare. Is 10 is less than 20? Is key is less than air of J? Yes, and hence 20 as well shifted towards right hand side by one position. J minus minus. So value of J becomes what? -1. Is this a valid position? Reply me guys. No, and hence J will stop over here. It means so value of key should be inserted at J plus 1 position. -1 plus 1, that is 0. तो यहाँ पे की क्या होगा? Insert होगा. Please check. So key inserted at its appropriate position in this iteration. So अभी तक array sort हुआ है क्या? No, and hence one more iteration is required. So for this iteration, what will be the value of key? Value of key will be equal to 40. Right? Again, we need to find its appropriate position, and at its appropriate position, we'll want to insert it. So to find its appropriate position, value of key with all elements which are in our left hand from right to left. So 40 gets compared with 80. Is a 40 is less than 80? Yes, and hence 80 should shift towards right hand side by one position. J minus minus. Is a 40 is less than 70? Yes, so 70 भी क्या होगा? Shift होगा. J minus minus. Again 40 gets compared with 60. Is 40 is less than 60? Yes, and hence 60 as well gets shifted towards right hand side by one position. J minus minus. Is a 40 is less than 50? Yes, and hence 50 as well gets shifted towards right hand side by one position. J minus minus. Is a 40 is less than 30? Is a 40 is less than 30? No, 40 is not less than 30. Right? Now pay attention. Sir, अगर ये 40 30 से लेस नहीं है तो साथ कंपेयर करके कुछ फायदा है क्या, और वो कंपेयर करने की जरूरत है क्या? हेलो फ्रेंड्स, इफ 40 इफ की इज नॉट लेस देन 30, डोंट यू थिंक ये अननेसेसरी कंपेरिजन हो रहे हैं क्या? कर रहे हैं कंपेरिजन्स? नो. आर यू गेटिंग व्हाट आई एम सेइंग? It means in insertion sort algorithm, unnecessary comparisons are getting skipped by design. Hello friends, are you getting what I'm saying? By design of this algorithm, unnecessary comparisons are getting skipped. Right? तो यहाँ पे क्या होगा देखो, if key value of key is 40 is less than 30, no. And if it is no, तो इसके next position के ऊपर 40 क्या होगा, key insert होगा. It means unnecessarily 40 is not getting compared with 20, 10 and so on. Hello friends, are you getting what I'm saying? It means sir अगर यहाँ पे और एक element होगा, let's say 90, pay attention. अगर यहाँ पे और एक element होगा 90, it means if value of key is equal to 90, तो सर ये 90 कितने element के साथ compare होगा? 90 gets compared with 80. Is 90 is less than 80? No. And hence 90 will get added after 80, right? तो सर ये 90 कंपेयर होगा क्या 70, 60, 50, 40, 30, 20 से, 10 से? No. So unnecessary comparisons are getting avoided by design, right? And hence we can say insertion sort algorithm works efficiently, yes, for already sorted input sequence. Hello friends, for already sorted input sequence. Do you agree with this? For example, let's say, pay attention, let's say सर अगर यहाँ पे elements है 10, 20, 30, 10, 20, 30, 40, 50, 60 ऐसे elements है, तो in first iteration key का value क्या होगा 20. So 20 gets compared with 10. So 20 gets inserted after 10. In next iteration, so इसका मतलब हमारे लेफ्ट हैंड में कितने एलिमेंट आए? 2 elements है. Now in next iteration 30 will be the key element. Sir, if key gets compared with 20, is 30 is less than 20? No, and hence 20 के बाद 30 insert होगा. So इसका मतलब हर एक iteration में कितने कंपैरिजन होंगे? In every iteration, in best case, yes, total number of comparisons is equal to n minus 1, but in every iteration, yes, only one comparison takes place. Right? And hence total number of comparisons in best case are, yes, order of n minus 1 ना guys, order of n minus 1. अगर n minus 1 number of comparisons हो रहे हैं and in every iteration अगर सिर्फ एक ही comparison हो रहा है, so total n minus 1 number of comparisons takes place, and it comes out to be what? It comes out to be order of n, which is the best case. Hello friends, is this fine? This is the best case, right? And hence for insertion sort, yes, for insertion sort, worst case average case is n square, but best case is what? Omega of n. But don't you think guys, insertion sort algorithm works efficiently for already sorted input sequence by design? Do we need to use any logic of flag? अरे हमें यहाँ पे कुछ flag वगैरह use करने की जरूरत है क्या? No need to use of any flag, right? And hence by design, insertion algorithm is efficient by design. Is this fine guys? आपको ये insertion sort समझ में आया क्या? Right? Now let me just write here only efficient time complexities is इसका best case है n log n. आपको ये सिर्फ मालूम होना चाहिए, that's it. Right? And sorry, worst case is n square, right? And यहाँ पे आएगा n log n. You should know only these things. Sir, ये कैसे आया, कैसे हुआ? No need to know, right? You should know only this table. आपको एक table मालूम होना जरूरी है सिर्फ, right? Or we can say you should know only this time complexities, n log n, right? Just a minute. Okay, so guys, if you see carefully, yes, out of these algorithms, average case, which algorithm is efficient one? Which algorithm is efficient one? Merge sort and quick sort. Merge sort and quick sort, because उनका commodity क्या है देखो, n log n, n log n, right? But pay attention, very important. Merge sort, yes, takes extra space. Merge sort takes extra space on an array, and hence, yes, and hence on an array, yes, on an array, quick sort algorithm is considered as an efficient one. Hello friends, is this fine to all of you? On an array, quick sort is efficient, right? So if array size for larger input size array, for smaller input size array, insertion sort is efficient, and for larger input size array, yes, quick sort is efficient. So आपको सिर्फ ये याद रखना है. Hello friends, you just need to remember this point. पे point लिख के दिया आपको. For smaller input size array, insertion sort can be considered as efficient one, and for larger input size array, quick sort can be considered as efficient one. Hello friends, have you understood this? तो आपको ये टेबल सिर्फ याद रखना है, आपको याद करना है टेबल ये, और ये पॉइंट याद रखने. Right, don't worry, this file I will share with you. ये इमेज में आपको शेयर करूंगा on Git. Is that fine? So here we have finished with searching and sorting algorithms. तो आपका आज सर्चिंग एंड सॉर्टिंग के ऊपर क्या होगा, टेस्ट होगा. Is that fine? So shall we stop here guys for today? आज के लिए यहाँ पे रुके क्या? We almost extended 15 minutes, right? तो अगर आपके कुछ डाउट्स होंगे, so you people can ask your doubts or onto the WhatsApp group. Our team will give you the reply. आपको वहां पे आपको आंसर देंगे, right? Thank you very much. So shall we stop for today? Yes. Thank you very much. We'll meet tomorrow. Thank you. Bye bye.